General equation of a hyperbola. You should be familiar with transformations of graphs. In this lesson, we will graph hyperbolas and write the equation of a hyperbola given its graph. Recall that we arrived at the general equation of an ellipse by stretching the unit circle x squared plus y squared equals 1. The equation of the standard hyperbola is similar to the equation for a circle or an ellipse, except one of the squared terms is negative. To see what the graph looks like, we first examine the intercepts. If x equals 0, then we are left with the equation negative y squared equals 1, which has no solutions. So this graph will not touch the y-axis. If y equals 0, we get the equation x squared equals 1, so we will have intercepts at negative 1 and 1. The points 1, 0 and negative 1, 0 are called the vertices. As we move up and to the right, the graph will approach the line y equals x. We will demonstrate this behavior with an example. If x equals 10, then x squared equals 100, so y squared equals 99, and y is the square root of 99, which is just slightly less than 10. The further we go to the right, the closer the y value is to the x value. To draw the graph, we need to draw these lines that the graph approaches, called asymptotes. For the standard hyperbola, we draw a box whose corners are up and down 1 and left and right 1. We then draw the asymptotes diagonally through the box and sketch the graph from the vertices toward the asymptotes. For the hyperbola y squared minus x squared equals 1, we have the same asymptotes, but the vertices are now on the y-axis at plus and minus 1. We can stretch the hyperbola the same way we stretch the ellipse. Dividing x squared by a squared stretches the graph left and right by a factor of a. Similarly, dividing y squared by b squared stretches the graph up and down by a factor of b. Here is an example. The x squared term is positive and the y squared term is negative, so this is a hyperbola with vertices on the x-axis. The horizontal stretch factor is 2, so the vertices have x values of plus and minus 2. The vertical stretch factor is 3, so the asymptotes go through points which are 2 units left and right and 3 units up and down. The hyperbola is then graphed, starting at the vertex and heading left and right toward the asymptotes. If we wish, we could shift the graph as we have done with other graphs. Here is an example in the other direction. We are given the graph and wish to write the equation. The hyperbola is headed left and right from the vertices, so this is a hyperbola whose x term is positive. The center of the graph is at a height of negative 1. The x value of the center is halfway between negative 1 and 5, which is 2. So the center is at 2, negative 1. We subtract these values inside the parentheses. The vertices are a distance of 3 left and right from the center, so the horizontal stretch factor is 3. The asymptote box has corners that are 5 above and below the vertices, so the vertical stretch factor is 5. The squares of the stretch factors appear in the denominators. To recap, if the x squared term is positive, the vertices will be on the x-axis, a distance of a to the left and right of center. The asymptotes are drawn diagonally through a box whose corners are a distance of a left and right of center and a distance of b above and below. If the y squared term is positive, we follow the same procedure, except the hyperbola goes up and down instead of left and right. The vertices are a distance of b above and below the center.